Right, so we're going to talk about blueprint advice. So, as with the other similar advice sections in the other classes, it's some more in-depth tips and tricks, more specific ones, some smaller things at times as well, but just things I think would be nice if people are aware of them. They might not always be immediately obvious. I wish someone would have told me this kind of thing. But it should be noted that a lot of this stuff is pretty advanced or pretty specific, or there's a lot more to say than what we can say in just a couple of minutes. So this is really meant to be an overview of stuff you want to think of. It's not necessarily meant to be, here's a full explanation of exactly how to deal with it. Okay, So it's going to be the overview. It's going to take additional reading into. I actually have a blueprint in-depth course that I have done, and some videos that are online on our online Unreal Engine learning resources as well. And you can find a lot of what I'm about to say in depth in that about 2-hour long class. So I advise you to check that out. We're going to talk about these things, or briefly touch on these at least. In terms of learning Blueprint and getting into it and how to use Blueprint, there's a number of things. I think everyone in the team needs to understand Blueprint to an extent. It's used so much across Unreal. It is such a powerful but also very visual language and system that everyone should be able to understand it. So there is no excuse of saying, well, you know what, I'm the artist or I'm the designer, I'm not going to touch it. I think everyone needs to have rudimentary skills in Blueprint. Art tools, for example, anything. Definitely also don't avoid the power of Blueprint. It is so interwoven into the engine. Again, it's so powerful as a feature, so don't avoid it. Make sure that you use the power of it, that you can have a long discussion about how much Blueprint vs C++, but to say that we're going to do 99% in C++, that wouldn't be a good idea, I feel. Okay, a lot of this is discussed where you can say, well, it should be 20% in Blueprint, should be 30%, should be 40%, but not 1% or less. That wouldn't work. It might require some initial hand-holding and training for some. It suddenly opens up this world of possibilities for the wider team to get involved in building some of the functionality or to tweak it. Some things might go wrong. Some people might get carried away with the power they suddenly have, or do weird things, or use ticking for everything. So it might require training, but it's the best idea that you can have, especially if you're a bigger team, is to sit down together, figure out how you're going to work together. Because if you can figure it out, you're going to be in a much better position than to just say, well, they can't use Blueprint, we're not going to use Blueprint for this. I mean, in the long run, that is not helping. So make sure everyone is on board, everyone knows how to use it, what not to do in Blueprint, best advices, and so on. Make sure you establish a style and rules right away, I would say. Michael Eller in the community has put together a really nice style guide, which you can find on GitHub. It's pretty much conform with how we're working internally. And at least, even if you don't want to follow it letter to letter, and you don't have to, but at least it will. The idea is you have to think it over, that there is actually a style. And even between us two, when we were building the project, I mean, the upper picture is what Mario was doing. This is what I was doing. Even that spread out, and we're 2 people. Okay, so you really want to consider, what is the style of Blueprint? How do we comment? How do we do the lines?
Why do you put an example without connection?
Oh, that was actually a good example, because I said disconnected here. Because sometimes when you disconnect things, it's not obvious if that was an accident, if you forgot it, or if there's an intended purpose.
Yeah.
So when you disconnect things, always make sure you comment on it. I have my own rules that says I do DOP.
You put your style.
I do my DOP, DOP, disconnected on purpose. So I mark it. But whatever you do, you mark it so people don't get confused. But you want to think through the style. Right? References, really important. Blueprint is content. C++ is code, is C++. They're completely different. Content is loaded only when it is needed. That means that if you reference Blueprint, the Blueprint script will only be brought into memory when it's actually referenced, when it's actually needed, when the other thing is brought in. And that can have a huge impact on projects. So this is an advanced topic. This is definitely not possible to explain in a few minutes, but you want to really think that through. That impacts casting. It impacts many other things. Use the size map, use the reference tool. When you right-click in the editor, just very briefly to show that. Use these 2 tools, size map and reference viewer, to understand what it might be referring to, what might be brought in when that blueprint is loaded, and work with that. If you don't do that, you'll get things like this. This is not the way to go. This didn't even fit the picture. It's actually much bigger than that. So when that one blueprint is loaded, it referenced everything else, and then essentially half the project was brought in, which also results in a giant size map, which says at least 1.1 gigabyte. I like that it gave up, at least. So definitely do think that through a bit. Because of that, in turn, casting and other references should be controlled. You can soft load assets. You can do, as you see in the bottom picture, async load asset. That's only going to load the asset when it is needed. If you don't do that, if you just say set static mesh or spawn actor or something, anything like that means you have a hard reference to this other class, means that if the blueprint is loaded, this other thing is loaded, and that other thing loads this, and then you're off. Async load asset would only load it the moment it's actually executed in the script.
Also, it's good to notice that when you cast, you're also referencing that class.
Any form of, literally a reference, any form of mention to that other thing brings the other thing into memory when this thing is loaded. Not at execution, but the moment it loads. Right? And again, a lot of stuff to mention there. You can do a parent blueprints and then loop it through the parent and all kinds of techniques, but this will take some investigation. Bridging between C++ would definitely help, but a lot of tips there. You get to ideas like this. For example, you have if you want to set it up, there's a C++ class for like interactive item, then there's a blueprint under it that might hold some additional functionality, but then there's additional blueprint under that for pipe, bucket, flashlight, like the individual items. The art assets for the actual pipe are located solely in here. This has no art assets, that has no art assets. That kind of techniques you would want to deal with, because then when this is loaded, it still doesn't load any content. Likewise for this. And you want to think of stuff like this. So just to open up your eyes to, kind of things to consider. If you're going to cast or otherwise reference, because cast kind of just means referencing in general for me. Situation-dependent functionality that's occasionally present, that can cast to core functionality. So you're in a level and there is a button on the wall. The button in the wall can probably cast to the player, because that's occasionally present, the button. The player is always there. But the other way around would be a terrible idea. And so there's all those kind of considerations to take into account. That kind of continues on that, right? From the player to a traffic spawner would be a bad idea unless the traffic spawner is always in memory anyhow, and so on and so on. Contained situations where a button references a door, that's fine. It's a little self-contained group. Going from all kinds of stuff to a central class like the player, that's fine. The player is in memory anyway. Things to consider. You can use C++, so how did you do this exactly?
Yeah, basically we created the blueprint function library is a function that is going to be it's a library of functions that are going to be always loaded in memory, are static. You don't need to call them from any other actor or object. So you can do things like, in this case, add an enemy. So we call the game mode add an enemy, and because we did this because we are casting to our current game mode that has the particular function add an enemy. So we did it in C++ because in this way we're not casting to the game mode blueprint, for example. So you don't need anything else, and you're not casting any reference. So you're using only code that is always loaded in memory anyway.
Do you remember where this one game mode you said? Was it? Where did this go? Game mode, I think.
Yeah, it's in game mode.
Yeah. So here you see, we can just add enemy. It's also easy. It makes the blueprint much cleaner as well. It's just very easy. Just click, add enemy, you're done. No reference, right? That gets routed to C++, and it automatically ends up in game mode where you can continue. That kind of stuff is really, it's clean, it's better for performance, everything works better. Similar for variables, it's the exact same thing instead of events.
Well, in this case, the only difference is that because it's blueprint pure, it looks like a variable, but it's a function that doesn't need
an input execution.
Yeah.
The whole balance between C++ and Blueprint, that's a tricky thing. It's a long, endless discussion you can have for the next 3 years or so. It really depends project to project. It depends on the team as well. It depends on the preference. They both have strengths. For example, Blueprint works better with content, because it is regardless content, so there's some advantage there. And there's a few recommended approaches. So in general, you can compare the two. I'm not going to read through it, but you can read the slides as they appear on the video. So there's some pros and cons as mentioned. And again, there's some cases where C++ is typically better. You can read through it as the slides come by. Whereas Blueprint has these advantages. So it kind of helps to identify a little bit like what's typically for C++, what's typically for Blueprint. But again, it's case by case. There's always going to be exceptions. There's always preferences. But you definitely can't get to a point, I feel, where you use 99% C++. That would be a bad idea.
Totally agree.
If you get to a point where you use 99% Blueprint, is probably a bad idea. But for very small games or particular applications, that'll be fine. But if you do a bigger game,
you say that because you do that. You did that.
No, well, yeah, no, that was 80%. No, but I mean, for if you are building a small game that's literally just, for example, one developer, and there's no problem at all with doing all of that in Blueprint. But for anything bigger than that,
for the sake of sustainability, I mean, and keeping up everything, functionality like core functionality should be in C++, and anything that is level dependent or content dependent or a prefab, like so running a prefab, would be
absolutely
Blueprint.
Ideally that is the case. If you're a very small developer,
of course,
very short game, it's fine with all Blueprint.
You
can do almost everything in Blueprint.
It all depends on the team.
An example of what that could look like and how you could set it up. There's always a hierarchy. There's always a C++ one and a Blueprint one. Like there's always that partnership between the two. There's the same thing, but it's split into two. That's a model that could work well, where the C++ one always holds the core functionality, always holds the most important variables for other reasons, because it makes the variables easier to read. It reduces the costing to the Blueprint class.
And also be aware, this is related, that when you create a new C++ class and you didn't have that, you are going to have to reparent the Blueprint class, and that can make that can go wrong.
Not fun. Neither is it fun if you put the variables in the Blueprint and then later on it turns out you want to move them to C++. It's also not fun. So for that reason, think of that in advance. Just put that stuff directly in C++, even if the rest of the class is pretty much empty. But it's just the act of it existing just makes it more scalable in the future. Right, but Blueprint is better for content references, as mentioned, and the Blueprint is then used in the world, so it's that kind of partnership. Okay, performance with Blueprint is actually reasonable. It's obviously not the speed of C++, but it's rarely a real problem. Typically, if a problem with Blueprint performance comes up, it's more likely the user than Blueprint itself, I would say.
Yeah, and
as with any scripting language, you can do stuff in a wrong way.
Yeah, right? And ticking can have a big overhead.
Yeah, I think I got it on the next slide. So there's some exceptions. Weak hardware, mobile is not going to like it necessarily that much, depending on what you're doing. So you're going to be more careful, might use more C++. You got a functionality that's repeated in lots of actors and is continuously running, makes it even worse. Probably definitely should be C++ at all times. For example, a strategy game, having every soldier or unit entirely Blueprint driven is probably a bad idea, because there's so many of them. Anything that's heavy on maths, loops, logic connections, it's probably better in C++. So, we tried to make a theoretical test case for how Blueprint performs. Again, this is not necessarily representative of the real world, but it did paint the picture at least in this test case. And you can see that Blueprint, the red line, is really expensive the more iterations we did in our test one. However, if you look at the green line, green is C++, so there's a pretty huge difference there between C++ and Blueprint. But the moment you run that in shipping or in dev, so outside of the editor, the Blueprint, because these two, the yellow and blue ones are also Blueprint, they're performing much, much better. Still slower than C++, but much better. So there's a few things to take out of this. Blueprint is slower, but not necessarily slow. However, the editor is hugely offsetting the performance and is not representative in any way of the real performance. So do not get hung up on how it's running in the editor. Okay. There was a ticking and the timers that you mentioned. Ticking is typically the most common cause of performance loss.
Yes.
Turn off tick by default, like you mentioned when we talked about programming. For all the blueprints in the project, so you have to consciously re-enable it when you really think you need it. There's a command called dump ticks. If you just type dump ticks in the console, it's just going to give you a list of everything that's currently ticking. So you have a nice little list. Oh, I forgot that one and that one. You can use timers, as we see here on the image. And the timers are a better way than using tick to update something. So instead of updating it frame by frame, you put it on a looping timer and you update it slower.
Mm-hmm.
And you can do all kinds of other cool stuff with it. You can do like random float and range, and you can make sure that every blueprint that has this timer runs on a slightly different loop, so they're not in sync. So they're not going to overlap and spike, cause a spike in calculations. And you can even slow down the ticking. You can make sure the ticking slows down or is disabled when you don't look at the blueprint. All of that is very simple, one function to add or something like that. When we get to collaboration, it's a common question. Blueprints are binary files, so you cannot diff them. You cannot merge them. There is, however, a built-in diff tool, which is what we're seeing on the image here. But the built-in diff tool is not typically part of our daily workflow. This is not meant to be like normal programming scripting workflow where you just keep merging it as you go along. It
would be a branching case or something like that.
Yeah. So the best thing to do is really to keep it separate. Make sure that you don't have multiple people working on the same blueprint. That's a bad idea. If you split functionality off in different layers, so you use you got the hierarchy, there might be a few hierarchy classes of blueprint there. There's also C++ above it. There might be, some function libraries, anything like that. Like you fragment up the functionality so you can have multiple people work on different parts of that whole system. That is better than one giant blueprint that everyone tries to work in.
Anyway, if you have two team members trying to work in the same blueprint, I would say you have a problem of design.
Also, yes, because again, using the framework classes better, for example, also leads to fragmentation. It splits it up more, and that's the way to go. So, for example, that's an example of that. Different things. It's not just a car. There is like another blueprint above that. There's multiple C++ classes above. There's components. There's a child actor for the headlights, data table, some other function libraries, a data asset there. Like it's completely split. It's going to be much easier to collaborate on. It's also safer, in case ever something goes wrong with one of these, it's not all the functionality saved in a single thing. And as we're getting towards the end here, you can run the game, or the engine, as however you want to define it, with -run, compile all blueprints, and it's going to compile, as the name implies, all blueprints, which allows you to find all the errors in the blueprints. Because if you don't do that, it's actually pretty difficult to see if all the blueprints in the project are still correct, if they're still compiling. Because there is no easy way to say compile all the thing. It's not like C++ where you got to compile it. So sometimes it's difficult to know that something has broken, and that command would help you. You can do an isValid getter or setter, or isValid execution. It's not a function.
Check references.
And an isValid pure function as well. And all of this makes sure that things don't get executed if they're not truly existing. So you prevent an access null error. So it's always good to keep embedding that, especially in dangerous cases. You can mark things as deprecated to ensure that a blueprint function is still there, or the entire blueprint even, I think.
It can compile, but
it's still there, it still works, it still compiles, but other people can't access it, can't use it anymore in new cases, I think. Because that also prevents the case where you delete something in blueprint and something else was relying on it, and now that doesn't compile anymore, and that's not the way to go. So make sure you educate a team to not just remove things. They have to be careful with it. They might break another blueprint that relied on it, so be aware of what was referencing what. And secondly, as mentioned before, just got a casting and referencing strategy. Don't just go wild. And that brings us to the end. Thank you.